Chapter 3 is quantified sentences. Okay. This is using for all, for universal, and existence, that exists. So you have to know how to write in symbols if you are given a sentence, and vice versa. Okay. So you have to know whether to use for all, or there's some, or there exists, or none. Every is for all. Yeah. There are things, existence, there exist, there are, or some, there's at least one, they're all the same. There exists. And you have to know also the negation. Okay, if you have negation of for all, you get there exists. But the not continue. The not continue here, yeah? Okay. Don't forget this one. Sometimes students forget this part. And if there's no there exists, it becomes for all, and then still you bring this one over here. Or you can have both. Then you change both. For all becomes there exists becomes for all. Okay, so you have to know how to translate like this to English language, or from sentence transform to symbols. The second part is the truth value. If there is for all, your solution set has to be all U. Okay, all U is true. Then it will be true for all. There exists, you need just one that is true. Again, there will be truth table like this. Okay, if you have both, you have to know there are some parts, right? So for example, X is 1, 2, 3. Okay, and you see this one is all true. That means for all cases, it's all true. But if there is one false, so it's not true for all X, for all Y, only one. Where is that? This means all have to be true, right? And the other one is this one. The same thing, right? This is true, there's one false. Okay. This one, I already gave you the... Did we do exercise chapter 3? Yes or no? Not yet, yeah? Carrie, yes or no?
Oh, we haven't discussed
Hmm?
the answer. We haven't discussed the answer.
We didn't discuss the answer.
We haven't discussed the answer for chapter 3.
Okay. So I need you to ask me question first before we go to the exercises. Anyone that you cannot do? This one is just every natural number for all X. For all X, Px, X in N, right? Implies X bigger than 0. Right? So this one, I think straight away, I'll convert into symbolic. Not all, so use not all. No birds, no exists. Okay, what about this? This one. For all X, if X is guilty, then X is prosecuted. That is the direct translation. Then you do it in natural form. Everyone that is guilty will be prosecuted. Okay. Don't worry about the grammar because I won't punish you for the grammar as long as you write a complete sentence. Okay. So for all X, if X is guilty, then X is prosecuted. Okay. But again, to make it more natural, everyone who is guilty will be prosecuted. Okay. Part B is a little bit different. Last time you asked whether, why, how, we should know. Normally for all, we use implication, right? And the exist, we use and. That is the normal one. But here, part B, you are forced to be given for all and n. So this is still okay. This, when you translate, you will say for all X, X is guilty and X is prosecuted. It's not as nice as part A. So what you will say that everyone is guilty, and prosecuted. That's it. Everyone is guilty and prosecuted. This one, there is someone who is guilty and prosecuted. Yeah. This one, it's a little bit different. There is X. If X is guilty, then X is prosecuted. If there is someone who is guilty, then he is prosecuted. Okay. If you say if first, if there's someone who is guilty, then he is prosecuted. What about E? If first, yeah. If everyone is guilty, if everyone is guilty, then everyone is prosecuted. So that is the answer. Okay. Let me see thumbs up if it's okay. 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 Symbolic form is much easier actually, rather than to do in language, right? Oh, wait, my battery. Okay. I will stop share because I want to write in the board. Okay. Okay, where were we? Okay. Okay, number 7, yeah? For all x, for all y, px imply qx. Determine the negation. Determine the negation. So you have to take for not x, for all x, for all y, px implies qx. This is the question, this is the negation. So you will write, bring this here, it becomes this y, then don't forget the not. Okay? Now, this is very, very important. If you don't remember this one, you cannot continue. P implies Q is not P or Q. So this one you need to change. Not, okay, this becomes not Px or Qx. Because you can only do this with conjunction or disjunction. Okay. If you see this, you put not here. You put not here, you will put not here. Not. Okay. Then you can do not is P, then N, not Q. So you do here. Px and not Qx. Okay. So if you are given from the English sentence and then you do two symbols and you have to go back to English, then there is X, there is Y, whatever given Px and not Qx. Okay. Is this one clear? Yes, Tom? Okay. That's it. Yeah? Okay. Now, B. Let me write B here. Let me write B here. The X is X, the X is Y, Px and A, Px and Qx. So supposed to be XY. I just realized this, sorry, yeah? XY, XY. So this one actually, because this is, it is possible, but normally if there is XY, we want to put XY also, but it's okay. If this only regarding X, but normally if there is XY, you also have XY. Okay. Okay, now take the not, yeah, not. So assume this is PXY. They are not equal, yeah? That is the question. But you are asked to find the negation. Don't put equal here. This is the negation. Then you put equivalent to. So you have for all X, for all Y, not PXY and QXY. So I just change this for all X, for all Y, and bring the negation here. So this becomes not PXY or not QXY. So this is quite straightforward. Okay. You can do C and D because it's very similar to this one. Okay. Now we do number 8. So is this okay? We do number 8. I erase this one. Okay. Determine the truth values of for all X, Px, and the exists X, Px. Okay, so A U is 7, 8, 9, 10. Px x plus 1 bigger than 10. Okay. It's easy to write in a truth table. Okay, so you put X in U. 7, 8, 9, 10. Okay, and X plus 1. What is X plus 1? 8, 9, 10, 11. And then you do X plus 1 bigger than 10. 8 bigger than 10. 9 bigger than 10. 10 bigger than 10. 11 bigger than 10, right? You compare this with that. So, for all X, Px is false since solution set of Px is not U. Or you say 7, 8, 9. You can just say 1, but 7, 8, 9 is not in the solution set. To be true, for all X to be true, this has to be all T. Yeah. You can say in any way, whether you can say solution set is not U, or you can say that it's not true for X is 7, but this is the right way to write. For this one, is true since since ada ada solution SS of PX is not empty. Because ada satu jawapan. Okay. Because when X is 10, 10 plus 1 is bigger than 10. So there exists X. Okay. Or there exists X equal 10. Such that X plus 1 bigger than 10. So your reasoning can be any true reason, correct reason. Okay. But normally we use for all the U, the solution set has to be U. For all to be true, solution set has to be U. For this to be true, solution set cannot be empty. That is the rule. Okay. Clear, yeah? Okay. Okay. The calculation is very easy. This is sekolah rendah. So make sure you don't do silly mistake here. Okay, this is very, very easy one. Okay. We can do it again for the B. I can just change this for B. Okay. For B, U is 1, 2, 3, 4, 5. Px, x squared bigger than 20. So you put 1, 2, 3, 4, 5. And then you put x squared 1, 4, 9, 16, 25. And then you put x squared bigger than 25. So you compare. They're all not bigger than 25, right? So this is F, 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 F. So still this is not U. So the same thing. Okay. And then this is also false. Oh, okay. Is false since this is empty. Because this is not true. Not true means solution set is there is no X. It is empty. So both are false. Okay. Is this okay? Okay. So part C. 1, 2, 3, 4, 5, the same thing. Log 10 of x less than 1. You know, without calculator, you can figure this out. If you remember log, we have log 10x equal a, x is like 10 to the a, right? That's why you have like log 10 100 is 2, since 10 squared is 100. I think we learned this before. Okay, so log 10x less than 1 means x less than 10 to the 1. Right? Okay. So these are all less than 10. So if you put 1, 2, 3, 4, 5. You don't have to do this, but you can find log 10 of x. 1 is 10 to the 0, right? So this is log 10 is actually 0, right? Until this is all less than 1. Because if x is less than 10, I know log is less than 1. So you can write the real log, but since this is all less than 10, so this is all less than 1, you can put. So there are two ways. One is to find the log and check is less than 1. Another one is you can use this and straight away get all to be true. So in this case, this is u, all t. If this is true, this is automatically true. Okay, and this is not empty. Okay. Okay, I want to go to number 12. Number 12, yeah? You have to find for all x, for all y, pxy. For all x, there exists y, pxy. There exists x for all y, pxy. And there exists x, there exists y, pxy. Okay. We are not given the u in specific. The u is given in general. For part A, u is all integer. So you have to understand what this means. This means this is true for all x, for all y. This means for all x, there is a specific y. This means you choose one x and it's true for all y. This is also the easiest one. At least there is. At least there is. Okay, so pxy, x plus y is x. Is it true for all x and for all y integer, x plus y is x? Yes or no? This is only true if y is 0, right? If y is 0 for all x. Only true. How do you write your answer? Okay, so the first one, for all x, for all y, pxy is not true. Not true, you have to give a counter example. Since let x is 1, y is 2, then x plus y is 1 plus 2 is 3, is not x, which is 1. Or any other counter example. We know it's only true if y is 0. Right? So it's not true for all. So you can give any value, but don't give y is 0, then it will be true. Okay, for number 2, for all x that is y, pxy. This is true. Okay, since let y equals 0, then for all x integer, x plus y is x plus 0 is x. Because there exists y. Yes, there exists y, so let y is 0. How do I know? Because I have right here. Kita conting. Yeah, this is true for all x, no matter what x is. Because x plus 0 is x. So that is the y. Yeah, that is the y equals 0. Number 3, there exists x for all y, pxy. What does it mean? You want x plus y is x. For all y, like if y is 2, is there any x? So x plus y is x. Is false, right? Since pxy is only true for y is 0. Okay, this is not equal to x for all y. Make sure you know how to write your reasoning. Because this we say for all y, but it's not true for all y. It's only true when y is 0. Okay. The last one is easy. This is true because, for example, ini je lah. Ambil je lah. For example, x is 1, y is 0, for example, right? As long as y is 0, just take one example. 1 plus 0 is 1. Okay. So as long as y is 0, you can take x anything for the last one. This is the same for the second one. Is this okay? Which part that you don't understand, you can ask, yeah? Okay, for part B, it's very similar. But x But this one is xy equal x. Right? So this is only true if y is 1. Right? Only true if y is 1. So this is not true for all. If we let xy, x1, y2, don't choose y equals 1. So if just change this. Xy is 1 times 2 equals 2 is not equal to x, which is 1. Okay. And for all x, there is a y is true since we let y is 1. Then x times y is x times 1 equal x. Okay. And this is also false since this is only true for y is 1. So x times y is not x for all y. Right? Very, very similar. And this one, you can change y to 1. So 1 times 1 is 1. As long as y is 1, you can use x is 2. 2 times 1 is 2. Right? Okay. Okay. Part C. C, D, and E, they are very similar, but the U is changed. Right? The U is changed. So let's look at C. Let's look at C. U is Z, E x y, xy is 1. Now, when is this true? Zhijian, your name is first in my Zoom. Zhijian? Tengok muka sikit. Is that your pet, your dog?
No.
Okay. When is this true? For x is what?
For x and y, both are 1.
If x is 1, y is 1, or negative 1, right?
X, yeah.
Both negative 1. Okay, this is the very basic one. You have to think first. When you multiply two integers, how do you get 1? This is the only one, right? That is true. Okay, so for all x, for all y, it's not true. You can let like this, right? So xy is 2, which is not 1. Like this. Okay. Because we want true for all, but this is not true for all. It's true only for that. What about this? For all x, there is a y. It's not true for all x, right? It's not true for all x. For example, if x is 2, what is y? So this is false. Okay. You say we want for all x. No. Because since, for example, x is 2, there is no y in z such that xy equal to y equal 1. Because z, right? And the same thing for all y. Because it's only true for y is 1. This is false. For example, if y is 2, there is no x in z such that xy equal x times 2 equal 1. What do you want to multiply 2 by to give 1, which is integer? This is true. For example, already there. 1, 1. Or negative 1, negative 1. Yeah. So the simplest case is there exists. As long as there is an answer. Okay. For part D, this is okay already? It's clear, yeah? And you have to think what it means by any part that you want me to explain again. Okay, Zijan? Is it clear? Anyone else? Yes? No?
Why the question 2 and 3 is equal to 1?
Why?
Mm.
2 and 3? Ni?
Uh, why
This
2y is equal to 1?
is the question.
Mm.
This is the question. Okay. It's not equal to 1 actually, but this is the question. I said, this is false since if you let x is 2, there is no y. This is the key. There is no y. You cannot change this because this is the question. Right? They said for all x, okay lah. For all x, I give x is 2. Can you find the y? Can you find the y 2 times y equals 1? Ada tak?
No.
Tak ada. That's why I put there is no y. So this one is the question you cannot change. This one is the question you cannot change. Then you have to decide whether ni soalan dia lah. Ada tak y, ada tak x?
Can we write like 2y is not equal to 1 in exam?
2y equals 1.
Like not equal to 1. And write in another
I already
way.
put here.
Or
I already put there is no y. If you want to put, if you don't put this, you will put xy equals 2y. Then you want to put not equal to 1 for any y in z. Pun boleh. But you don't need to put this.
okay.
Boleh.
Thank you, doctor.
Ini pun sama. You don't want to, you want to put no x here. You will say this cannot be 1. Then you put for any x in z. Pun boleh. Because you are saying tak sama dengan 1 kat sini kan? Because this is, we want it to be 1. It's okay. Cara tulis dia lain sikit lah. It's never 1 kan? That's why there is no, that's why it's false. Okay.
Thank you, doctor.
Siapa yang bertanya ya? Harry ya? Because ni gini tak nampak mulut bercakap. Anyone else? Yeah, you have any question? It's clear, yeah? Okay. Now, if I change this to Q, what is the difference? Ni dah tak betul lah kan? Because, okay, if I change this to Q, XY equals 1, I have other example kan? Right? For example, X is 2, Y is a half. Right? So many. Tak semestinya 2 je lah macam tadi. Okay. Now, Carrie, I want to ask you a question. Is this true or not? Is this
No,
true or not?
no, not true.
Why?
Because when y or x is equal to 0, 0 is rational.
If
So
X or Y equal to what?
when x or y equal to 1 over x, something like that, so it would not equal to 1.
Contoh apa? Kalau X sama dengan apa?
When x equal to 1 over 8,
1 over 8. Kalau X 1 over 8, Y is 8.
when x equal to 0,
Since let X equal 0 or Y is 0, right?
Mm.
Then XY will be 0, not 1. You have to think for all. You have to think for all possible numbers in rational numbers. Okay, don't choose 8 or 1 over 8 or 3 1 over 3. Memang semua boleh kan? But if X or Y is 0, you cannot get 1 over that. Right, Carrie? Okay, so number 2, for all X, false lah kan? Kalau X 0 kan? For X 0, ini is 0, not 1. Ini pun false jugalah. Kalau Y 0, ini sama juga, equal 0, not 1. Yang ini pun true, ini pun okey lah. 1 and 1. Okay, or you can put this example or many example, except for 0, 0. Okay, the last one is the same as this, because for Q is in R, so exactly the same answer for part E. Okay.